think I hit record. Yeah. All right. Konnichiwa. Uh, 日本語が少しわかります. I'm learning a little bit of Japanese because I'm going to go visit in March. Welcome to the stream, everybody. Today should be an interesting stream. Let's talk a little bit about what I'm trying to do. Let's look over here. Here's a Zig checkout. This is master branch, just pulled recently. And oops, if we look at not this directory, but the actual source tree here, here's where all the source files are. That's all the Zig source files. All right, here's a C++ implementation of Zig. Now, when you run the build right now, like if I ran Ninja, if I typed it correctly, you can see it's already cached. But what this is doing is it's first building this one, and then it's using this one to build this one, and then it uses this one to build itself. Now, the problem with this is that there's, I see we're getting ahead of ourselves here. The problem with this is that this code base is much nicer than this one. And also there's features in this code base that we want to use that are not implemented here, such as inline switch cases, which are pretty nice. Also, the new for loops. Wouldn't it be nice if we could just implement the new for loops only in here and not in here? Let's try to delete this code base. Okay, but we don't want to lose the property that you can take the Zig code base and run, make or whatever, and have it do the build. And we don't want you to have to like wget, some kind of like binary, and then I don't know, you have to remember which one to get. And then if you're doing like a get bisect, you don't know, it doesn't work. Like, no. We're going to maintain the property that you can build from source with any commit or any like tarball of the source code that you download. Now, here's a cool thing that's happened recently that you might not have, if you're not keeping up with the Zig news, you might not be aware. Jacob Lee, who I don't think is in the stream, but maybe he is, did a whole bunch of work recently on the C backend. So much work that, in fact, if we run the behavior tests with the C backend, yeah, Jacob Lee did great work. He also fixed the fact that stage 3 and stage 4 were not byte for byte identical. Anyway, you can see that this is most of the behavior test passing, 92% if you compare it to the LLVM. So that was 1279 out of the LLVM backend. So that's 92%. That's a high percent. In fact, it's such a high percent that we now have the capability to actually build the self-hosted compiler with only the C backend enabled. Let's put this in, I don't know, stage 4C, I guess. Let's see, no lib files. Let's do a release build. And let's do, let's give it an explicit target. Now, here's a cool thing. This is not going to use LLVM whatsoever. So we're actually learning the true, like how long does it actually take the compiler to build itself when we only do the C backend? Wrong syntax for the target. So you can see it's doing semantic analysis. Oh, wait, it's done. I didn't get to finish my sentence. Because normally you have to wait for LLVM emit object. You know what I'm talking about? But in this case, there's no LLVM, so that's gone. So it's a lot faster. We can also make it way faster than that. Now, what this did is it outputted some C code. So there it is. And if I were to then put the C code into a C compiler, it would take a lot longer than 4 seconds. It would take, I don't know, 40 seconds to compile this, what is this, 2 million line program. However, outputting C is not actually easier than outputting like x86 64. So this is kind of roughly what I expect building the self-hosted compiler in debug mode for x86 or ARM64 to take, something like that. Anyway, so big shout outs to Jacob Lee for getting the C backend this far. And now this can also be improved quite a bit. So there's a lot of things about the C backend that are inefficient. So if I just kind of scroll down here, let's see what I hear. I know there's like, oh, here we go. So like string literals are emitted like this. Like this is just a string literal. And I don't think it needs to be like this. I think we can probably have the C backend figure out that this could have just been a string literal. So point being, you know, first things first, you get it working, then you clean it up. So obviously there's a lot of room for cleanup here. This is not very maintainable as a source code. It does compile though, which is the important part. So this is going to be only one component of our process here. Okay, so here's the problem. Can you compile this with zigcc? Yeah, but that's not actually impressive because we're trying to... Here, I can just do that real quick. But let me explain why that's not actually good. Like, it's not good enough to compile it with zigcc. We need to compile it with system tools. But sure, I can run that test for you. So let's do... Oh yeah, it has this flaw too. Bracket depth. So that's another thing that the C backend needs to be improved with. So you can work around this with bracket depth equals, I don't know, 512. Let's time that too. Also, it has a bunch of these warnings. Yeah, let's get rid of the warnings too. So these are all like to-do items, right? These should be addressed. I mean, this is a new toy, right? We just got this working, so you know, don't worry. That's not how this is gonna look for a long time. I expect this to take about 40 seconds ish. Can Arrow compile it? I don't know. I haven't tried that. Okay, but let me explain why this is not actually valuable. Who cares if zigcc can compile it? The problem that we're trying to solve right now is building from source when you don't already have Zig. Because if you have Zig, then you can just run zig build and you can build the compiler. Problem solved. What we want to do is make it so that if you don't have Zig and you only have a C compiler, you can get Zig. That's the goal. So that's why, I mean, an Arrow is written in Zig, so that doesn't solve the problem. zigcc is written in Zig. That doesn't solve the problem. I mean, this is an interesting data point though, so let's look at it. Okay, it took about a minute. But let's take a look. Okay, yeah, it does work. I don't know. Let's do. Oh, it could. Oh, by the way, and it only has the C backend installed. So in order to use this, we would actually need to do something like this. Build exe. Let's just do hello world, I guess. It actually is fully capable of building itself, but just to start with something smaller. Let's do O format equals C. Okay, well that didn't work. What went wrong here? Well, we could turn on the interesting. Well, we can turn on the debugger. We can figure all this out, but that's not the point of today's stream. Let's try to focus because there's a lot of different directions we can go. So here's my point. If we look at this, it's 90 megabytes. Okay. So first of all, here's two problems. If we were to commit this into a new stage 1 code base, and of course there's some problems like this, there's some problems like this. Okay, we can work those out, no problem, right? And we can even make it be a little bit smaller, maybe even by half. Let's say that we do a lot of cleanups on the C backend and it gets down to 45 megabytes. Okay, here's two problems. One, that's a 45 megabyte file that you're committing to the source control. And every time a breaking change affects the compiler itself, you will have to replace that code with a new code. So that's like, I don't know, 50 megabytes optimistically. That would have to get of a binary, basically a binary file. It's not going to have a clean like lines changed or something like that. They'll have to get updated every time there's a breaking change. That's going to create a large source repository. I don't want that. Okay, that's problem number 1. Problem number 2. This is x86 64 specific. So remember that when I ran this command, this is the command that I ran. And if I didn't pass this target, it would infer the native target. So not only would it be x86 64 Linux, it would even potentially use some CPU features or like SIMD stuff that other computers don't have. So that's problem number 2. If we commit this file, it won't work on Windows, it won't work on Mac OS, it won't work on ARM, all that kind of stuff. It would require manual cleanups in order to make that work. Okay, and there's another problem too. Let's say that we do those manual cleanups. Well, what happens when I have a branch, which I do, where in my branch I have 5,000 insertions, 4,000 deletions, and counting. The branch is like 80% done. Well, what am I going to do? Am I going to port all this stuff over to the manually maintained C compiler? That's not a good idea. Also, no surprise, surprise, none of the contributors to Zig want to edit a C code base. They just want to contribute to the Zig code base and only the Zig code base. So that's the flaw that's the third flaw, I guess, of doing this. So there's 3 flaws there. And previously my attitude was, all right, well, let's just suck it up and do it because it'll be nice to build from source and we'll play by the rules of bootstrapping and all that stuff. Okay, but in the short-term future, I also said it's okay if we temporarily regress our 01 bootstrapping. Which means that I'm okay with having a binary blob checked into the source repository if it lets us cruise into the future faster. And then someday, maybe after we write a spec, someone can make a C implementation of Zig. An implementation of Zig in C. And then we can unregress 01 bootstrapping. We can use that one to build the Zig compiler. Kind of like with Rust, they have, like mrustc, that kind of thing. So if we're going to allow bootstrapping to regress, that means that we can check in a binary blob, but we've identified 3 problems with checking in this one right here. Okay. Put this aside for a minute though, because this could be a useful component of the building from source process. So let's put that down for a minute. Now, let's talk about what WebAssembly system interface is. I'm on my other desktop here, my other checkout of Zig. I should probably go through this process again for you. So let's say I'm on this branch here, and we're going to try bootstrapping through WASI. Here's what I've done on this branch. Let me back up a little. Let me back up for a minute. Remove stage 1. Okay, so I already have this pull request open. All it does is it removes the ability that you can pass this flag. Okay, and that's nice. This is a nice deletion. It simplifies the compiler. And we're basically committing to the fact that you have to use the new compiler. You can't use the old one anymore. But it doesn't take away the old code base because we still use the old code base to build from source. Now, I have to implement async await before we can do this. So this is kind of a prerequisite of everything. Even the thing we're doing today, it's a prerequisite is async await. So that's something I'm working on also in a branch. I have to get that done. But I want to have some fun. So I'm thinking ahead. Once I do get async await done, what comes next? And today we're going to kind of explore what comes next after this prerequisite's done. So we do this remove stage 1 thing here. And that's this commit here. Okay, and then on top of that, let's look at what these commits actually do. That's too big. Let's look at what this one actually does. I know that the red's hard to see. I'm sorry. Okay, next, I added into the build system a new option where you can pass in WASI Bootstrap. And let me just run it for you. Okay. This command, wait, let me make sure I don't have any changes. Okay, good. This is a new flag I added to the build script. Now, when I run this command, it's going to do, let me actually put that verbose flag back on. Okay, here we go. There's the command. It's going to do a, oh, I can get rid of that. I don't know why that didn't work. It worked before. Wait. It's going to do a release small build. That's what I was trying to point out. It's going to target wasm32 WASI. Okay. Let me actually just go fix this because I expected this to work. And it's not like we're going to use this anyway. How is this still here? I thought for sure I deleted. I thought I did this in this commit. That's very strange. Well, let's just get rid of this then. There. It looks like I just had some like vestigial junk that I was able to safely delete. Okay, so here's the command that we're actually running. Build exe, release small, wasm32 WASI, okay? And we're putting it into this directory. And now I made this flag. This flag enables that only C thing, so only the C backend is enabled. And it also disables some other stuff like autodocs and like, what else does it disable? It disables like print targets. It disables everything basically except for the ability to make a C compile a Zig, like run a Zig command like this, but with the C backend. That's the only thing that the output's going to let us do. So we're creating a small as possible WASI build of the compiler that's only capable of outputting C. Now, why do we choose WASI? This is a good question. And the answer is it's the only virtual machine target that LLVM supports. And it's nice to use LLVM's fancy optimizations so that the output ends up being very small. Okay, so we outputted this file. Never mind this for a minute. We end up with a 2.6 megabyte binary blob. And this is a WebAssembly file. Now, here's the cool thing. If we do wasm to wat, and then I output it to, we can look at that. Okay, here it is. Now, this is almost 1 million lines of code, but it's just a textual version of this, right? 2.6 megabyte WebAssembly file. Now, here's what's cool about this. If we scroll down a little bit, we can see that these are only the external functions that it requires. So it needs to ask the system to how to exit, get the command line arguments, get the environment variables, get a random number, open and close file descriptors, read and write, list contents of a directory, get the current time. This is for the progress bar. We could delete that if we wanted to. Delete a directory, delete a file. You get the idea. But this is, if you look at this list, it's only 25 functions. So everything else here is just logic. It's just a small, nice little VM code that we can interpret. And what's nice about this is that unlike this 90 megabyte target specific C file, this is a 2.6 megabyte virtual machine. So it's cross-platform. You could even run this on on a weird system like a custom OS that you just built that's yours that doesn't even have POSIX support, all you have to do is figure out how to satisfy this interface. Okay, so the idea is, remember what the goal is. The goal is that we want to be able to build any commit of Zig from source without an external dependency. So we would need to commit this to, or I guess this, I'm just focusing on the size. We would need to commit this to the repository every time a breaking change in the compiler affected the compiler itself. For example, let's say that we implemented the new for loop syntax. Okay, great. We don't have to update this. Okay, but let's say that we wanted to use the new for loop syntax in the self-hosted compiler. Okay, now we have to update this, and now we can start using it immediately. So 2.6 megabytes, still a little painful, but a lot better than this. Okay, but we can maybe do even a little bit better. So, for example, what if we did something like this? Turns out it actually gzips pretty well. What is this number? It gzips down to 824 kilobytes, which is much smaller. And so what we could do is we have C code that is a minimal WASI interpreter. It's C code, not Zig code. C code. It also has just like a minimal gzip implementation. We ungzip it, just in memory. Fine. Look at how small it is. Whatever. Do it in memory. Ungzip it. Run it through the interpreter, and then using this, remember it only has the C backend enabled. So then we interpret this to build itself. So remember this code. So ungzip, interpret this to build this, outputting the C code this time. So now we end up with basically this file right here. And it's target specific, but it's fine because you built it for your target. And then you just compile that with your system C compiler. Remember, that's the input, a C compiler. And then once you have that compiled, then you just run zig build. And then that's your stage 3. That's the idea. Sounds cursed. I love it. All right, Megan wanted to see how small does the WAT compress. I bet you it's bigger, but let's try it out. So there's this one, and then the text version. It's an order of magnitude bigger. Okay, well, what do we need? We need a minimal WASI interpreter in C. Okay, before I move on to that point, though, Stevie has a great question. Is it still acceptable to have a WASM bytecode as part of bootstrapping, even if it can't be audited like the C source? No. So it's not acceptable. So this is the regression. This is what this means. We're regressing the bootstrapping being like purity thing. Now, it would be convenient. It would be very convenient. No one's going to be bothered by this except for people who are trying to do a pure bootstrap from source. Now, those people are going to have to start hopping, from like 0.10, and then they use that to build some version where basically every time we update this file in the Zig repository, they'd have to introduce kind of like a stepping stone step for the pure bootstrap, where they used the older version to build that one. So that's a regression in the sense that use case is worse. But that's accepted. I'm okay with that. We're going to regress this use case for a few years, and people are just going to have to deal with it. Most users don't have to deal with it. Only a few. It's a more niche use case. I still care about this niche use case, but it's fine. We can have this niche use case suffer for a few years, And then at some point, someone will make a different implementation of Zig in C, and then that will solve this problem completely. And then it will go away. That's the plan. Okay, I'll answer some questions before I move on here. Is it still stage 3? Yeah, it's still 1, 2, 3. Look, 1, 2, and then you zig build for 3. There you go, 1, 2, 3. And if you did zig build again, you'd get the same binary. I think I just answered this question. Okay. Try running WASM opt on it. Oh, I didn't even know about that. That's an interesting thing. Okay, how do I walk me through this? How do I run this thing on it? Do I just run it in file? Okay. Just holy shit, they have 04. All right, let's do 04. Let's do OS, actually. OZ. Let's do OZ. Oh, dang. Does it overwrite the same file? Okay, so we were at 2.6 megabytes before. Let's see what we get to now. Yeah, this is fine because we can run this. We would only have to run this operation every once in a while. Hey. God damn it. All right, where's the output? In file. Bro, just tell me how to use it. Oh, come on. Oh, there it is. It's way down here. I got a suggestion for this person. Put it right here. Jesus. All right. I could have guessed that, though, to be fair. All right. So let's take a look at the relative sizes. Okay, it didn't really do much. I mean, so the thing is, I don't know how this works. Like, what does it use LLVM or does it use its own thing? But like, this one's already done. Like, it's got the LLVM release mode on. So, I mean, kudos for getting a little bit better than LLVM. Like, maybe it's still worth doing. But it's not gonna be. Yeah, it's not a magic bullet. But let's see how far down it gets to. Okay, gzip at max. All right, tell me what the setting is for gzipping at max. I bet you these are about the same. Yeah, they're barely different. Is it 9? Okay, let's try that. Oh, Z-Standard got it down a little bit. So the question is there like a liberally licensed Z-Standard C implementation that's... Because if I look at like the... Here, let's take... Let me show you what I'm trying to say here. Where's the files? Okay, over here in Zig Bootstrap, I just happen to have like only the necessary files here. What the hell? So let me just do this. There we go. The total number of... we can go one more here. Okay, it's 1.9 megabytes is the Z standard source code. So we actually lose more than we gain by committing the Z standard code, C code, into the code base. However, it might still be worth it because, wait, also, isn't there a higher one? Anyway, let me finish my sentence. It may still be worth it because the Z standard code or the gzip code would not change very often, almost never. However, whenever this code would change a few times, so, or regularly even. Where's the most serious setting? 19. Okay. Let's go. Ooh, that one's really low. Okay, so that got down. Let's see what we got it down to. Sorry, I know I'm interrupting myself constantly. Okay, we got it down to 638 kilobytes. So okay, there we go. And we'd have to commit like the Z standard. Oh, long. What is this? It's the same. So we'd have to commit the Z standard source code, which is like, what is it? What did I say? 1.9 megabytes. But it just pretty much wouldn't change. So maybe it's worth it because we cut off another 200 kilobytes every time we have to update the WASI thing. Okay, so now that we've played around with this stuff, you kind of get the idea. So what about a minimal WASI interpreter that only, here's the important part, that only supports these, because any code that does anything more than this is a waste of time and space. We don't want to wait for it to compile. We don't want to maintain it. We don't want to bother figuring out how to like run some WASI function on Windows when we don't call that WASI function. We only care about these. So what we need is a bespoke WASI interpreter that is minimal and only supports these features. And you know what? It should not support atomics, bulk memory, exception handling, extended const, multi-value, mutable globals, non-trapping FP to int, reference types, relaxed SIMD, sign extensions, SIMD 128, or tail calls. You know why? Because we'll just turn all of these features off when we create the WASM build, and then our bespoke WASI interpreter doesn't have to support them. Okay, so I think that we've gotten through, we've gotten through this point. All right, now we're on this part. How far can we get? Well, funny you should ask, because I happen to have been working on a minimal WASI interpreter already. And here it is. You can go play with the code. It's already open source. And check it out. I'll demo it right now. Oh, wait, this might be actually a really good idea. Wait, no. Because of this stuff. That's still a thing. Okay. So let me show you what's going on here. Let's delete this. Let's make this bigger. Let's get rid of all this junk. Okay, what do we have here? Let's get rid of this, this, this. Okay. Look at that. It's only one file. It's only, 1,800 lines of code here. Let's build it. Do I have any fresh changes? No. Okay. Oh, look at this. It's a Zig WASI interpreter. All right. Now let's do something fun. Here, I will create the behavior tests. This is how we run the behavior tests. This is using the LLVM backend. Okay, but watch this. Now I'm going to target WASI. Okay. Now, if I run wasm time on this, you can see that we pass all the tests. Actually, let's go with release small, because that's what we're trying to work with here. Okay. Ta-da. Why is it called wasm32 WASI? This is the architecture, and this is the operating system. So, for example, you could do x86, 64 Linux, but we're doing WebAssembly 32-bit WASI as the operating system. Okay. Check it out. Here is this code base. It's fresh. It's only a few days old. Here's the file that we just produced. You can see it's going. This is a debug build of this. Aha. Same output. So there we go. So we already have this interpreter that is fully capable of running the release small behavior tests of Zig compiled to WASI. If we look at it, there's a main function which just loads some stuff, sets up some stuff. There's some types here, and then finally there's this main loop right here that handles all the opcodes. You can see there's not that many opcodes. And then there's this part right here that just notices which function you're trying to call and then calls it. So for example, let's do fd write. We just go down here and we implement, we find what you're trying to write with the WebAssembly memory, and then we do it actually on the system. Yeah, and for those who want to know, I actually haven't tried this yet, but let's see how fast it is if I actually optimize the interpreter itself. Okay, it's kind of instant. If you optimize the interpreter, it's not bad at all. Okay, we should definitely use a debug build though, because it's under construction. Okay, so this is a Zig code base. It's not a C code base. That's a problem. Now, here's the thing. I could have started writing this in C from the beginning, but that would have, to be frank, sucked ass, because I would have just run into all sorts of problems, and then I wouldn't have been able to develop this thing in the span of 3 days and got to a working interpreter thanks to like Zig being really productive. So it's actually going to be faster for me to get it working in Zig and then either use the C backend to convert it to C, or just manually port it, but manually port a working code base as opposed to, as opposed to trying to, like, I've had to debug this code, and debugging it in Zig is much nicer than debugging it in C. So anyway, where are we? Right, so how far can we get? Well, we got the behavior tests working, but okay, there's a bigger question. What about the actual real thing that we're trying to be able to do? and it's the zig.webassembly one. So it's this one. I don't know about the optimized one. We could try that in a minute. Let's just do this one for now. Okay, so here we go. We're doing it live. I actually don't know what happens when we run this. It's probably going to crash. So let's do another build just in case the release one was still going. And then let's do, okay, real deal. Let's go. Oh, we hit a to-do. That's interesting. Okay, so 1750. Ooh, this is compelling. We can just go implement this. Okay, so that was part 1 of the stream. We're at 50 minutes. Any questions? Part 2 is going to be coding, where we're actually going to go implement stuff. So the native Zig backend for the target needs to be near 100% before Bootstrap will work. Native Zig backend. I don't know. I don't understand the question. I don't know what a native Zig backend is. How do you keep track of all the stages and building builders in your head? Sometimes I don't, and I get confused, and then I feel embarrassed. What's the rationale behind this approach? Is it just a binary size thing? Well, I just spent 50 minutes explaining the rationale, so I don't know. Maybe just go back and watch it again, or ask a more specific question so I can help. I mean, like, which part of that 50 minutes do you want me to review? Delete all this C++ code. Some of it deserves it. Blah, blah, blah. Okay. Oh, you just got here. Okay. No, it's okay. Sorry, yeah. No problem. Didn't mean to be harsh on you there. Yeah, I don't think I'm going to repeat the whole first section, though. So, yeah, you might have to just go catch up. Can you try the optimized build? Maybe they're using weird instructions. I'm going to get it working without that first. Well, we will do that eventually. You know what? Fine. I can just put the optimized build in there. It doesn't matter. Okay. Oh, if. I don't handle if. So there's, let's see. Let's see how many opcodes are unhandled. If, else, that's it. Just 2. Surprisingly, they haven't been used yet. But okay, there you go. Now they're used. We can go implement those. That's fine. Let's start with the other one though. I'm happy to move on to the binary n one in a minute. Are the necessary WASI functions going to be stable, or could it be that adding some new functionality requires to extend the WASI interpreter too? Yeah, that's a good question. So point being, like, right now it only needs these, and the interpreter will only have these. Now, if we if the Zig compiler does something new on the system, it's going to add another function to this list, and that's fine. We can just add more support as needed. The nice thing about this is that the interpreter is bespoke. It's only for the purpose of exactly this, and so we can just add support to the interpreter in the same commit that we add the dependency on it. Yeah, it's interesting, like, that if is not really used here. So, well, that's bur if. Yeah, it's not used. There's no if used here. I guess they just lower to a different, because you can do if by using like block and like break if, like bur if basically, and that's how LLVM works. Now, keep in mind that this file is optimized. LLVM has optimized this file. They just don't use the if else instruction. But maybe using the if else instruction is partly how binary n got it from 2.6 to 2.3 megabytes. So we'll add support for that. That's fine. We can even do that on stream today. But let's focus on the other thing first, because I think we might get further along. Okay. So where were we here? We're gonna do this one. So we're hitting this to do on 1750. Aha. Okay, so this is in. We haven't made it very far through the executable. We've only made it to asking for the arguments. So let's figure out what this function is supposed to do. Args get, argv buff. So presumably they already did args sizes or something like this. Arg sizes get. And in fact, let's go ahead and put this next to the other one. There. So presumably they already called this function and they figured out the count of the arguments and the buff size. Okay. So then they're giving us a buffer and we're supposed to write the args into here using this as the backing memory. Okay, we can do that. Okay, so argv, this is a pointer, and we need to put pointers to the strings in it, to the args. Okay, so what are the args? That's kind of the question here. Args1. Oh, here we go. E.args. We already have this thing here. Okay, so the other thing that's nice about doing this is that we can just kind of assume that we don't have to do a lot of like safety or, I don't know, handling out of memory. We can just panic. We can just assert stuff and it's fine because it's just for building Zig from source. So if it panics, when we convert this code to C, we'll turn all the asserts into panics. And if it panics when building Zig from source, that's fine. Then we just fix the bug and then move on. It's like, we're not trying to create a general purpose WASI interpreter. It's a bespoke, minimal implementation. That's the point. Okay, so let's just write the args into this buffer here. So e.memory, this is just a U8 byte slice, and these pointers just index into here. So like there you go. There's the pointer. In fact, I can even just pointer cast it to this type, and that'll actually be correct. Yes, now you're getting it. This is the point. Yeah. Okay, so let's see. What is the first argument? It's basically, okay, we can just do a for loop here. So these are the real arguments going to the process. And now we need to write into memory a little endian integer, which is an offset to here. Buff. Here's what we can do. Okay, so we have our buffer where we want to write the args in there. So for each argument, we need to actually do it. And then we need to put the null terminator in there. Okay, so we did that. Next, we need to write the pointer to this thingy. Let's do this a little bit differently. So let's do e.memory. It's nice because these can be used like actual pointers into the memory. It's like very simple. Okay, so we do their pointer plus an offset, which we're incrementing here. And we write that in there. Okay, then we increment this, and we put the put the 0 byte in there. Sorry, I know I'm kind of going back and forth on this a little bit here. There. I kind of like that one a little better. Okay, so we write the R to the buffer. Okay, next, we need to update this thing. So we need to put a pointer to this thingy, and basically it's this plus this. So let's capture this. Okay, we need to write this pointer into the appropriate place here, and it's going to look like this. Okay, WASM32, the pointers are U32s, little endian. So we take the memory at this place. Oh, wait a minute. Yeah. Not at this place. At this place. There we go. And then we write the RB pointer here. There. I think that's right. So, and we return it in an error node T, so let's return success. Okay. Let me just double check this because it only takes a couple seconds to eyeball, and it takes a long time to debug this stuff. Okay. Yeah. So we take the pointer. Yep. Yep. Plus 1. Good. Okay, I think we're going to need to do stuff for U size versus U32. Other than that, we should be good. 1656. Okay, well, let's see how far we get. Now we're running on the same binary, the actual Zig compiler. Now, what we're expecting to see, if we get far enough along, is, I mean, we're expecting to see this, right? The help menu and then error expected command argument. That's what we're still working towards. So we haven't gotten that far yet. Oh, there we go. We're hitting index out of bounds on the memory. Okay, where are we? 875. Okay, we're just in like an arbitrary location, and it's trying to load from a memory location that's too big. So I'll try one little trick to debug, and then if it's too hard, we might have to do a different strategy here. So we're logging every single instruction that's getting run here. And then, I don't know, if there's something fishy towards the end, then that'll help us. Otherwise, I have a different strategy to figure this out. Now, what would be really nice is if I already had another working WASI interpreter, and I could just run them side by side and see what's different. But I don't know. I don't have that. Wow, it's a lot slower when you have to lock a mutex in order to print every instruction. Okay, so we're failing on this instruction, and the top of the stack is this value. So it's adding this number to, I don't know, the hard-coded index, and then it's too big. Why is it too big? I don't know. I don't know why it's too big. Could be a lot of stuff. So let's do something different then. There's two tricks that we can use to debug this. One would be using this secret debug function that I made. I added this like WASI debug function. So we could go in and sprinkle this somewhere. Like we could basically do printf debugging, like, I don't know, inside of main. Because we haven't even made it to usage yet. Like right here. We haven't even made it to here yet. So we could try putting like, you know, WASI debug. It lets you put a string and a value. We can start like littering these everywhere and see kind of like where we get. Kind of like narrow down where the problem is. That's one strategy we could take. Another strategy we could take is we could try to make the behavior test pass. But wait, you ask, what do you mean? You already said the behavior tests are passing. I lied. The behavior tests are only passing with release small. If I take this off, they don't pass. So they do pass with WASM time. But let's take off the debugging. Aha. See, we get a similar problem. So here's what I'm thinking. I'm thinking we try to get the behavior test passing without release mode on, and that will help narrow down the problem. Because we can do something like this. We can do binary search on our behavior tests to figure out which ones fail. And once we identify a test case that fails, it's only just a few lines of code. So it's pretty nice. So that's what I'm going to do. In fact, I already did it. Guess what? I did it already. So if we just do, I figured out that if I comment out everything and I only have a bit reverse on, it still fails. Ta-da. And I found out that it's this test right here, because if I take this one off, then it works. And I further found out that I can start commenting out some of the extra stuff here. So let's try to get this as minimal as possible here. Okay, still fails. What if I get rid of all these? Yeah, it is kind of like prepared cooking show, isn't it? We're going to run out of prepared dishes pretty soon, though. Okay, still fails. Nice. We're getting it down. It's down to only all this stuff. What if I do these? Oops, didn't need to build it again. Okay, still. Oh, I needed to build it here. Okay, now it passes. So that was too much stuff. Okay, let's keep trying to narrow this down. What if I get rid of these? Okay, it passes now. Okay, so far I've tried to comment out this block and the test pass, or this block and the test pass. So what the hell? Let's try to, I don't know. How about just this? Okay, now it passes. What the? Passes. Your guess is U128. In this state, it fails. I'm trying to reduce it more. If I only keep the U128 one up, it passes now. So there's more to it. What about just like half of them? I don't know. Okay, now it fails. What if I do this? Ah, now it passes. Okay, what if I just do like, I don't know, half of them again? Passes. Really? Fails. Is this as small as I can get the test case? Okay. Maybe the stack frame is getting too big. Well, it's not, it's indexed out of bounds. Oh, wait. Oh, holy shit. It is the stack, isn't it? Oh, yeah, it's just the stack. God damn it. Okay, let's just go make the stack bigger then. The stack's just hard-coded. There we go. Here's more stack for you. How did I not notice that? God damn it. Okay, now it works. Jeez. Okay, let's turn all these back on. God, the answer was in the stack trace the whole time, ironically. God damn it. Oh. Okay, maybe this actually does work. Wait, was the stack trace on the Zig compiler one too? Holy shit, wait a minute. Oh, it's too much printed. Okay, let's go back and run that again. Okay, this is all working. Holy shit. Okay, I turned on all the behavior tests. Let's go. Okay, this is gonna take a minute. Watch it need even more stack space. This was taking a while with the release build of the behavior tests. So this is the debug build of the behavior tests with a debug build of the interpreter. Have I seen WASM 3? Yes. All passed. Let's go. All I had to do was bump the stack size. God damn it. Well, maybe it works on the compiler. Let's see. Okay, so we have... Here's a compiler. Boy, it's taking a while to just print the help menu. I'm a little concerned about this right now. Okay, that's not stack. That is heap. That is heap memory. Also, this is a very big number. Okay. Well, what do we do now? It's getting tricky to debug this. Maybe we'll use that other trick that I was talking about. Okay, what happens if they run the debug function? Wait, okay, I'm gonna read this comment. The WASI idea is fun and cool, but I can't help but think of using the raw 90 megabytes. He has lots of avenues of improvements, optimizations of the string letters, blah blah blah. And then if it was split into multiple files, what? Okay, but I identified 3 different problems with that. Can you address all 3 problems? Can you get the instruction address and symbolizer with LVM symbolizer? Oh man, so let me complain for a second here. Okay, this wasm to wat thing is pretty good, but look at this. If I do this, there's this like here's the help menu, okay? Oh, first of all, I have to do shit. I have to do -- help. What? Okay. Okay, so they have all these things. None of these are annotate every instruction with the program counter. Like here I'll do like enable all features. Okay. But it didn't do anything. So like here it'd be nice to know what's the machine code address, what's the program counter address. Doesn't tell me. Ah. You can print PC from the interpreter. Yeah, I have the PC from the interpreter. Here, I'll show you. Let's turn on logging again. Ah. Okay. All right, logging's on. So if I look at any of these, so the PC is printed in every line. Okay, let's try the printf debugging approach that I was talking about. Where are we? Okay, so we're in main. We're in main. Oh my god, I bet you it's in crash report.initialize. No, I bet it's not. Well, let's do it. So the main function, we gotta put this here because it's not a real WASI function, but I'm just pretending. Is there really no debugger infrastructure? That's a good question. Well, let's say that there is, right? What would I do? So I would load up the debugger and then basically just make it stop when it gets to like this PC and then see like how they do something different. Is that the idea? I'm down for suggestions. If you have like debugging suggestions. I mean, I can add a debugger to this code. You see what I'm saying? But like, it does a little bit go against the goal of trying to keep it minimal. Why does the same address work with local get and not with i32 load 8? So you're looking at this one and i32 load 8. Where do you see this? Oh, right here. Why do you think this is the same address? Higher up? Well, this is the one that's not working. So this local get this is what's been loaded from the local. And then this is added to a secret, not a secret, but an index that's part of the encoding for this operation that's not printed here. Okay, so we enter main. Let's talk about what we're about to do. Oh, wait a minute. Okay, I noticed one thing here. Okay, so I was thinking it was going to go into this function, but it's actually not. It's going to go straight into here. It's going to assume that you did a build object. So we actually might be a lot farther along in the process here than we thought. Yeah. So let's actually put a debug statement in there too. Loop over args, and then what do we want to tell them? All args.len. Okay, I think that's enough. So let's do this again. Let's do bootstrap WASI. Okay, we're doing a rebuild. Now we have our like debug thing in there. All right, what are y'all talking about with these like local gets here? I see a lot of local gets. I don't know what you're talking about. You're saying that this number is the same as this number, and this is a local get, and this is this operation. Okay, so here's what this is going to do. I'll show you. Okay, there's an index that is in the code that's not shown here. Okay, that index is added to it's loading from a local variable, and it's not telling you which one it is in this debug output because I just am lazy. So one of this function's local variables, it has 4 parameters and 2 local variables, so a total of 6. It's loading one of those 6 things here. It's not touching this at all. It's not popping anything off the stack. And then it's actually pushing this value onto the stack. So it loaded this value out of one of these 6 things. That's what happened. Yeah. Okay, so I recompiled. Now we have some debug prints. So let's run this thing again. I want to turn off the warn, these thingies. But it's going to show our debug prints, though. Aha. Well, now we can see where we got to. Enter main, set up allocator, set up args, and it pre-opens. Wow, setup args took a long time. I wonder what was happening there. Loop over args, number is 1. Maybe I should pass to like build obj. Or maybe it should support. Why should it have to be build object? Shouldn't it support exe? I don't think it should be build object. Yeah, it does. It does build exes. Okay, so you're supposed to pass build exe to it. Let's try this again. So we're going to try to interpret this and then build, I don't know, hello world with the C backend. That's our goal here. So how's our... Is this good? That looks fine. Okay, so there's a proper invocation. And so we should see total args is 1, 2, 3, 4. Is the value at the top of the stack as printed before or after the before the instruction? So before local get, the top of the stack is this. Yeah, I could make the debug output a lot better. I've been extremely lazy about this. I've been just trying to guess correctly and save time. What's up, Johnny? You missed the first half of the stream where I explained everything in depth. Boy, setup args takes a while. I wonder if it's like allocating memory or something. I'm a little worried about how slow this is. Okay, 1, 2, 3, 4. That's good. Oh, now we're talking. Now we are talking. Okay, so this has something to do with the fact that with WebAssembly, it only has access to what you give it to with the pre-opens. Maybe I should use the current working directory for the input. Maybe just run some simple arg printing. That's a good idea. I will do that when this fails. Why didn't we see the help menu with no arguments? I will show you why. Because I have special code right here in the compiler. Short circuit some of the other logic for bootstrapping. So I didn't want any of this other fancy stuff to be supported, like print env or print targets or whatever the C++ thing is, whatever, blah, 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 blah. It's all garbage. All we want to do is this. The only point of this is to run build.exe, so it's the only thing supported. So if you pass in this argument, which we are, then we're going down this path. Oh no, it's the dreaded file not found without any without anything printed. Okay, well that's fine because we can add our own thing. Wait a minute. File not found. We don't ever return file not found. How is this possible? I wonder what file it's not found. So it's no int, right? Yeah, no int. We don't ever pass file not found as what the hell? Oh no. Maybe you don't have read access on the C backend. Error. Where's this error coming from? Okay, you know what I should do though is I should bump up. Let's change these from debugs. This is a little janky, but you know what? I'm gonna use scopes for this. Here we go. yeah, now we're talking. All right, so instead of log.debug, okay, we're going to categorize all these. So this one's going to be, okay, let's get rid of log. All right, this one's going to be CPU log. Okay, this one's going to be trace log. Okay, now we've categorized our logs. All right, compiler, please help me figure out how this API works. Let me just go grab a working example from somewhere. There we go. All right, we're just skipping the CPU ones. Don't care about the level. Okay. Okay, so we disabled the CPU, we enabled the WASI ones. Okay, so now we're learning about all the WASI calls that they're doing. Yep, there's the pre-opens. So I'm hoping that it'll tell us, like, why does it say file not found? FD right. FD is 2. That's standard error. Why is it failing to write to standard error? Isn't that standard error? Oh. Yeah, 2. Okay, let's answer some of these questions. Why is argc so large? Is that a pointer? Yes, it is a pointer. That is a pointer into the memory of the WebAssembly virtual machine, and it's just a big buffer, and that is the index into the buffer. These are both pointers, and the answer of this function will be written here. Do you pre-open standard error? Standard error starts pre-opened. Oh, yeah, okay. Il Capitano has it. Right, of course. Yeah, this is exactly writing to standard error, and here it is. And then it writes to standard error again. And There it is. Okay, case closed. Oh my goodness. And then it writes a new line. And then there's the new line. Okay. My goodness. Mystery solved. But what we didn't find was why does it say file not found? Okay, so let's try to figure out, does WASI do something? Is there like a different thing mapped to file not found for WebAssembly? Like, I don't know. Something other than noent? No. Try debug build of the compiler. And then what? Why does that help? So here's what we can do. We can enable logs of only the functions that we're going into. Okay, so now we're going to learn about the function calls that are happening here. Unfortunately, I don't have debug symbols. Okay, but we can figure out what these are. Would running it through strace tell you what file it's looking for? No, because we already did this, and the only way that it can access the file system is if it makes one of these calls. The virtual machine doesn't have access to the file system except through these extern functions. But what we can do, what we can do is figure out what function index it's in right here when it prints file not found. Maybe we get lucky. So, like, I don't know, maybe 772. So let's take a look. We need to redo this 2 watt thing. Okay, so this, we need to subtract 26, I think. Or add, we need to add 26. 772, 798. Okay, so we're like, I don't know, in this function, when the error is printed. Okay, which function is this though? That doesn't really help us, does it? I don't know why. Oh, I know why, because it's stripped. Yeah. Well, we could add debug symbol support. That's another approach. Or we could just keep going with printf debugging. If I were making a proper WebAssembly interpreter project, here's what I would do. I would slow down. I would support debug symbols. I would go and pass the WebAssembly auto-generated test suite. I would implement a disassembler. I would do all this stuff. And that would all be good ideas. But right now, it's just try to get lucky, hit a bullseye, and have a minimal thing that works, which is fun, but it's also requiring a little bit of troubleshooting. Okay, so let's figure this out. Here, let me show you the pre-opens code that I have. Okay, so I have this pre-opens buffer. There's a WASI FD, a host FD in the name. Where do we deal with these? There we go. So the WebAssembly code asks about each file descriptor. That's how it works. And if we find it, then we have it. Otherwise, we return bad F. What are the preopens that Zig needs? I will show you. Okay, so here's the preopens that we do. 0, standard in. 1, standard out. 2, standard error. Current working directory is in there twice. We actually open it so that it's open and we have a file handler. And then there's also the cache directory. So those are the pre-open. So if you ask about any of these file descriptors, that's what you get. And if you ask about number 6, you get ebadf. Okay, but the question is, why is it saying file not found? Okay, let's turn all these off. I want quiet output again. I think those just printf statements are helping quite a bit, actually. Let's keep doing that. I guess we disabled the wrong thing here. See ya, Eleanor. Maybe having it print the args is a good move. Why does it do arg sizes again? That seems pretty sus to me. Shouldn't one of the preopens have the standard lib in it? Yes, it should. Yeah, one of them should have the Zig lib directory. Okay, let's go take a look. Wait a minute. Yeah, I want to know why this is happening. Why are we getting the args again? That doesn't make any sense. It should only happen after setup args right here. Why are we doing it again? Is there like some WASI specific code here? Ooh, here's some. No, not that one. No more WASI specific code, so we're good on that front. Okay, let's just have it print the args. That was a good call. Oh, it has to be a null terminated string. Goodness. Okay. Why? Can we change that? Oh yeah, because it's going over the C boundary. That's why. Okay, let's just do this then. Okay, while this is compiling, I will go implement that in our code. What is this? Okay, so in reverse order, so it's len pointer. There we go. Okay, this has completed, and now we can run this. That could work. That's a nice idea. The WASM type invocation has mapter zig out. Yeah, I think that preopen is missing indeed. Be nice for this thing to tell us about that, wouldn't it? Ah, here we go. Okay, so arg0, arg1, arg2, arg3. It's good. Everything's good so far. But then we get file not found. Okay, so let's use the clue that we do know one of the preopens is missing. I think that is a nice clue. Okay, so we loop over the args. The 1, 2, 3, 4 here is just nice to know we didn't like corrupt the stack or something. Okay, now we're going to invoke compilation. Okay, while that's building, yeah, let's explore this. Oh, sorry, same code base. Let's explore where this like other preopen is supposed to be. Find, what is this, like introspect? Here it is. Wait a minute. Ah, here we are. This is the part I expect to fail. But notice that when it fails, it's supposed to print this, not just file not found. So here's some special code. Find zig exe path. Look it. Here's where it accesses the args again. Don't do that. Don't access the args again, you madman. Okay, I think that's definitely it, but let's run this thing since we now have some more debugs. So now I'm expecting it to get to done parsing args and not get to create the compilation. Yeah, see? Now I'm expecting it to fail right here. Yeah, there it goes. It goes into introspect. Why are you getting the args again? You don't need to do that. I already gave them to you. No, it's gonna be file not found. Yeah, okay, this makes sense. Yeah, all right. Oh, you monster. Find zig exe path. Okay, well, where's our actual... Oh, it's right here. Okay, self exe path. Override libdir. Okay. You know what? It'd be nice to not even run this code if we were provided this. Wouldn't it? Unless we need it somewhere else. We need it somewhere else. Okay. Because we want to be able to invoke ourselves as a child process. But isn't that optional? It is optional. Would you look at that? Okay, so we're going to edit this code. I think that you should just have to provide the ziglib directory. And then yeah, that should be good. Okay, but let's take a look at this code because it's pretty sus. Yeah, this is actually wrong because argv0 is going to be this one. It should be this one. I specifically made this one be arg0, but then this code is ruining all my hard work. Just going out of its way to do extra stuff that's broken. Okay, and then here it's checking the pre-opens. Okay, but the question still remains. Why is it saying file? Aha! This is where the file not found is happening. And it's not returning an actual helpful answer. Wait a minute. Okay, so this returns file not found from find zig exe path. There's just a try right here. I see. Okay, well, there should have been a catch and a fatal. That would have been helped a lot, actually. Okay, I know how to fix this. Collected enough information. Whoa, what just happened? Oh, I have switch tabs. Okay. I don't think fatal needs to have a new line in it. Okay. Well, that's already better in several ways. Wait, should we keep this null? Nah, we still should do it, actually. Okay, so can execve is false for WebAssembly. So then this will stay null, and this will comp time be eliminated. So this code will just never even be compiled anymore. Okay, so then you pass in the ziglib directory. Okay, and then this one wants to find it from self-sig path, but if it's not there, let's just call it P, I guess. That's a good point. We don't actually want it to require ziglibdir. The problem is if you pass in ziglibdir, it doesn't actually do the pre-open. You have to pass it as a pre-open. So we do want it to work with pre-opens, actually. Yeah, so let's actually fix this a little better. I think this is not good, actually. Let me undo all this. Okay, so we're still gonna do this, but we do need to handle it better. And that new line should go away. Okay. Okay, this needs to be fixed though. This code is completely wrong. It doesn't belong in here. Okay, we need to eliminate this code. So let's find out all the places that use it. Print end. There's a couple main places. Find ziglibdir from self-exe. Okay, this code seems fine. Let's do this. Then we can follow the red brick road. Okay, so here, this is going to give us a compile error for WASI. Ultimately, we need zig lib directory to work. So let's make this a little bit more complicated here. Okay. Okay, a little bit of boilerplate there, but now we're gonna have the ability to exit early on WASI. So, okay, how should this work on WASI? Well, let's take a look at that logic. Some of the logic's fine. We just don't want to repeat the args allocation thing. So that's good. Well, we have all args here. Ta-da. And there you have it. All args 0. What even are these paths? We need... We actually don't need the self-exe path. It's only useful for executing. I think I was actually right about that earlier. We don't want it to require zig libdir, but we also don't want self-exe path to be populated on WASI. We don't actually care about it. Good night, Glutiger. Yeah, I'm gonna end the stream pretty soon too. It's been a couple hours, but I think we can make progress on at least this thing, and then I'll probably call it. Okay. So I think the point of self-exe path. Let's see if I documented this. Maybe I did. Yeah, right here. So the only point of this is it's the path to your own executable for invoking ziglang. On WASI, it works differently. It just skips it doesn't go through a process. It just invokes it directly. So we only want if process.can exec v. Actually, can spawn. That's what we want, can spawn. That's true for Windows. False for WASI. There you go, see? So if we can spawn processes, then we want to do this. Let's invert this. It's a little nicer. Shouldn't it work if you provide /zig and then these fix ups can be done later? Yeah, we provide /zig. Yeah, you're right. I can do these fix ups later. That's a good point. I'm getting a little unfocused here. Fair call. Let me just get this back into a compiling state, and then I will focus again. Right, okay, so now we have a zig lib directory, and then what do we do? Okay, so we're skipping find exe path. Okay, in our case, it's going to go else. And we don't have a self-exe path. Okay, so we're finding ourselves here, basically. And what we're going to say is that... well, okay, let's say if it's WASI. Then we're going to handle it. Otherwise, fatal. Okay, that got a little weird. Actually, I'm okay with this. It looks pretty good. Can we even get to this else? I don't think so. Okay, we'll probably never hit that compiler error. And if we do, then we can just fix it. Okay, so if it's WebAssembly, then we're going to try to use preopen specifically on purpose. Okay, so what should the preopen be? Should be called like slash... like slash zig slash lib, maybe? I guess that's fine. So what is this code doing? So this code... oh my goodness, it's checking all sorts of stuff. I suppose it's actually this code. That we care about. Find zig libdir from self-exe. So we actually want to skip this part entirely. In fact, let's move this up so that it makes this code not even get compiled. And then we're just going to require the zig libdir to directly be a preopen. Okay, do we have like a cache of preopens or something? What was the point of calling init preopens? I know that this file up here calls init preopens WASI. What does it do? Init preopens WASI. Populate. Okay. Preopen. What's the point of this? Is it to emulate a current working directory, I guess? Basically, we want like this. God, I always keep doing that. So we'll add it here. Okay, so that should be good. Is this a good name for it? I don't know. Should it be one name? I don't know. Seems fine. Okay, so we do this, and then args needs to be different. Okay, we're getting a little weird here. I should probably do like the dash dash thing. I guess one name's good. I don't know. Okay, then the VM args is going to be, it's going to include the WASM file and then everything else. Yes. Woogie boogies. Okay. All right, I don't know what this code's supposed to be, but that's what we need. I'm just confused, like, what was the point of this init preopens thing? I don't know. I'll implement this in a minute. So let's say that we have this FD. Okay, what do we do? So path is lib, handle is FD. I think that's it. I need to know the file descriptor. That's the only problem. os.open, what's that going to do? I guess I can use path open. Okay, well, let's try that then. So we'll do, is there OS here? Open dir absolute. There it is. Absolute Z. There, see, that's a helpful error right there. There we go. Okay, I think we're back on track. I might have caused a problem for myself by doing this, but let's start from here. $30.83. Ooh, this one wants a proper. Okay, I see what's happening here. So this one just expects it to be non-optional. Now, in all cases for us, it will be non-optional. That's fine. We have syntax for this. It's called, what line was that on? 3083. It's called, I promise it'll be there, don't worry. Okay, what else is here? 2681. What? Oh, this function hasn't been called in a hot minute. Did I just find a bug in a standard library? 3 arguments found 2. Ooh. Open dir Z. pwd. Okay, so, oh, iterable. Ah, damn it. Okay, iterable false, I guess. Oh, it says true. Man, I'm not a fan of this iterable dir stuff. I liked it better when it was just regular dir. Because what am I supposed to pass here? True or false? Is there supposed to be like, oh, open iterable. Oh, so this is supposed to be false then. Okay. Problem solved. 3155. Oh, using os.open, that might be a good way to go, actually. Yeah, that might be the move. Perm. I guess I just pass. What do I pass? I don't know. Anyway, it compiled. So, yeah, that's why I had to do that. Okay. Anyway, so it compiled. I think that's an improvement, actually. Let's run the code again. Wait. Oh. Wait, why did I think it compiled? It's still going. Anyway, so here's this. Let's go optimistic, in fact, and turn off tracing. Okay, that is done. Now we can run it. Here we go. Build.exe, hello, from it, interpreting it. Okay. What the? Oh, I know what happened. I know what happened. More arguments are required. I really should clean this up. I just wrote this code and I'm already confused. I'll do it off stream though. So ziglibdir is first. Okay. Here we go. What's gonna happen? Hey, we got to a to-do. That's exciting. Okay. Should we turn back on the trace one? I feel like maybe we should have the trace one on. Now it's only going to set up args once. Good. Done looping over args. Maybe we'll actually get to like init. Oh, okay. Now fd stat get. Okay, well, let's go implement that then. Nice. All right, I'm going to end the stream in like a little bit, but we can do one more. All right. fd stat get. All right, this is some progress. Very nice. Okay, so these args are buff and fd. Oh, look, it's the same. And then it's an errno. Yep, okay. So let's do fd buff. Okay, great. Let's put it next to this one. Okay, it's actually the same. Good. Let's put our little trace in there. Okay, what does this function do? fd stat get. fd stat. That sounds a lot like file stat. Isn't that the same thing? Let's just figure out how it's used. Standard OS. I guess it just does this. I mean, there's the FD, and then we're supposed to write these things. Okay, so how is that different than a stat? File type, flags, writes. Goodness, writes inheriting. Oh man, I gotta figure out what all these things are. Okay, so file type. Well, that one's the same as the one above. Okay, FD flags. What is this? That's a U16. Writes T. It's a U64. What about writes inheriting? Same thing. Okay. Can I just write zeros to all these things? That'd be nice. Well, file type, I know what to do. File flags. Oh, geez. I like how it's all rusty. Man, this does not answer my question. All right. Forgot to rename the actual function I'm writing. Ah, thank you. Okay, so I'm thinking maybe just zeros for all of them except for this one. I don't know. What do we do with the answer to this? Oh, it's like mode. Okay. Oh, rights. Oh man, I have to translate all this stuff. It's gonna be super annoying. If I start doing stuff like this, it's gonna be really annoying to debug. I better implement these correctly. Okay, so here's the other way around. So it takes an input of the WASI one and returns the like. Oh, wait a minute. Open options from flags WASI. Wait, so that's going to WebAssembly. Wait, I think that's actually good. Yeah. So I can do this thing. I could do like, I don't know, fstat or whatever, and then I can just I can do this logic here, I think. I think. Rights T, FD flags. Is that what I want? Yeah, FD flags, rights inheriting. Yep. Okay. Oh. Man, this one's making my head spin. Does anyone have an implementation of this already? Let's see what Mr. Benjamin Fang did on this one. Nope. F-sync. I don't think this is right. Do they mean fun control? Is this what they're talking about? Oh man. Okay, I have an idea. Let's cheat. WASM 3 or whatever. All right, what do they do? Where's their actual real implementation? Blue pill. What is this? Some 4chan shit? FD. Okay, here we go. Ooh, we got a Win32 implementation. That's handy. Oh, they got ape. Nice. Oh, let's go. Okay, so they do an fstat, and then they use that to figure out the file type. Then they do fs flags. Okay, they just do all ones. Okay, that's the Windows check. Okay, this is good logic. I like this one. I think we can do the Windows logic. Remember, we only need this to work for the Zig compiler. We don't need this to be a general correct implementation. So this logic looks great, actually. To do? No, we're not taking the to do comment. All right, I got your Zig translate C right here. It's my fingers. Okay, so we're going to do an FD stat to figure out... Didn't I already implement this? Yeah, right here. My goodness. Okay, we get the pre-open. Create a file. We do a stat. Why are there two ways to do a stat? All right, whatever. Okay, so then we're going to do all that same stuff here. Okay, except it's a different layout. So here we have a U8. The alignment of the struct is 8. So it's going to be this one, and then there's going to be 1 byte of padding to make it U16 aligned. And then there's going to be 4 bytes of padding, and then it'll do these two things. Okay, so first we do the stat. Then we do... Okay, we don't need to do write int little. We're doing one byte of memory. Okay, so what are we writing to? The file type. This one. Oh, wait. Oh, that's so smart. Okay, wow, I was so smart yesterday. I'm gonna do that. All right, so this one has a byte of alignment after it. So I'll just treat it as a use16 and it will be correct. And then we just do this logic. There. Stat.kind. Got it. Boom. Easy. Okay, next we do flags. Yes, flags is next. It's another use16. Let's do, we need to do +2. That's only correct on little endian machines. I got great news for you, my friend. WebAssembly is a little endian machine. Okay, flags, 0. So let's say the interpreter is running on a big endian host. Okay, so this number will be a number, and then we write it to a little endian into the virtual machine's memory. So that's correct on every host. Yep, no problem. Okay, so we have flags. So that's the padding. Okay, then we have this. And now we need 4 bytes of padding after that until the next one. Now we're doing writes base. Oops. Okay, so I think that's right. 2, 3, 4. Wait, so the padding's here, and then we're skipping over 4 bytes of padding. There we go. Also, I made a mistake here. So -1. Where was the code I was copying from? 0 flags 0 writes base -1. All rights should be max int. Also, it's a U64. Okay, and then this is this. Whoa. Okay, is my hex logic right? 8 + 8 is there. And then this is a U64. U64. And this is max int. Ta-da. Man, this is pretty slow. Maybe if we let it run for like, I don't know, a couple minutes, we can try a release build. Or we can just let it run for a couple seconds and we already get to the next one. Nice, this is fun. Should I keep going? It's kind of a long stream, but we are making some nice progress, actually. One more. Okay, I like Stevie's attitude. One more. Yes. It's a good move. They're asking about FD6. Which one is FD6? I'm going to spy on him. Ooh, that's the Zig lib. That's a good one. All right. Path open. Okay, well, let's make a commit. I did something. Okay, the logs are organized. The pre-opens are different. We added, I don't know. Opens. Okay. All right, let's do one more. One more, then I'll call it. So let's do, what, path open? Okay, how's path open supposed to work? Ooh, that's a beast of a function. Holy shit. My goodness. All right. Well, let's do it. Okay, starting from reverse order. Wait, the FD's last? All right. Oh, it's a dir FD. Okay, starting from reverse order. FD. That's a pointer, so it's a U32. FS flags. Oh. FS flags, that's I don't know, it's an enum or something. We can do that conversion right now, actually. What is this type? It's a U16. Wait, no. That just means we do the U32. Okay. So U32, and then we do into enum WASI.fd flags t. Is that right? Oh, it's not an enum. It's just a U16. Okay, I'm getting ahead of myself here. Let's just do this. Okay, so FS flags, rights. We just learned that those are U64s. Okay. Wait, where's this selection coming from? Oh, it's my search. Okay. Rights base. O flags. All right, what's an O flags T? U16. U32 is the minimum. Okay, so O flags, and then we have pathlen, which is a U size, therefore it's a U32. We have path, which is a pointer, therefore it's a U32. We have lookup flags T. That's a U32. Oh, sorry, dir flags. And finally, we have dir FD, which is a FD. Okay, well, let's send all these to the function. My goodness. Why don't I just do it this way? Okay, does it return an error no T? Yes, it does. Undeclared identifier, WASI path open. Right, let's go find another WASI path. No? All right, let's put it after this one. My goodness. All right, let's try to use Zig format here. WASI path open. Meh. Fine. Man, Stevie, you told me I had to do one more. Oh, is my face dark? Here's what's happening. The sun's going down outside. My natural lighting is going away. Oh no, Yusuf. Oh, wait a minute. Right, okay. I do have one trick up my sleeve. It's this. Did it work? Yeah. Okay, what the hell is going on here? I32. U32. 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 16. Writes T is a U64. Oh wait, no. I'm doing this all wrong. I'm sorry. WASI dot blah blah blah. Okay, but the pointers have to be U32s. Unused function parameter. Oh no. I gotta use them all. Should we try to implement this? Jeez. It seems kind of important to open a path, gonna be honest. Check ma'am, check ma'am. Ha, we're not gonna do that. I love that they have ape support in here. That's amazing. Win32. Oh, you haven't learned about ape? Oh, you're gonna love this. Here, bookmark this page for yourself. Not this one. This one. Justine.lol/ape.html. You're gonna enjoy this. It's pretty cool. Yeah. Okay, what is going on here? Translate into regular ass flags and then call open at. That's what we're doing. Okay, cool. I'm gonna totally copy this code. What do we do before this though? Mem copy, whatever. Don't need to do that. Okay. I'm definitely gonna be done after this one. This is a monster. Let's just translate this code. Oh, flags. Okay, the and is good. Why is this commented out? I don't know. Okay, we have all these. What is this? O flat O dot. Okay, WASI dot O dot create. Okay, and this one is FD flag. Namespaces in Zig are so much nicer than C. Okay, we have rights. Ooh, is it right dot? Yes. Okay, and this one is, I don't know, OS dot. This is and. Ooh, host FD. That's the same identifier I chose to use. Okay, then we finally call open at. Yep. Okay, and then obviously we don't have this thing. This is ifs, so we need to make it actually if here. If delete. Else. Oh, nice call. Don't worry, that would still be. I bet you it'll be a ZIR error. Watch this. It'll be like an error on save, I bet. What is this? Oh, I put the if on the wrong side? Alright. Oh, reader. There it is. See? Ta-da! And in fact, anyway, yeah. Ooh, pre-open. Okay, so let's do the pre-open thing. Dir FD. Oh, I need to do this thing too. Oh God. Oh, this is so much garbage. Jesus. Stevie. Don't worry, I don't care about the nice alignment. Stevie, you made me do too much work. That's what you made me do. No, it's okay. I was gonna do this anyway. Oh, these won't work either. And it should be not equal 0. There you go. I got your nice alignment right here. All right, that's a deal, Stevie. Flags. It's gonna have to be a var for sure. I don't know. How about this? And then host FD. Host path. Where did you get this from? Yeah. Okay. Getting the FD pre-open when you should be getting the dir FD, right? Where? Which line are you talking about? Oh, this one? Dir FD. Oh, I see. Yeah, also that was a pointer, so that would have been weird. I mean, this would have been like way outside of the buffer. Okay. Okay, host path. It's this right here. Okay, so I can get that. That's no problem. E.memory path len. Ta-da. Open at, and then we just do catch error return to WASI error. There we go. Oh, look. Same thing. Right mem32 ho fd. Oh, right, because this is a pointer and we want to. That's the output. Okay. Unused function parameter. Uh-oh, we didn't use the rights inheriting. Did this code use the rights inheriting? Nope. They didn't use it either. Busted. Fucking busted. This is America. I inherited rights. We're not using the dir flags either. Are they using the dir flags? You monsters, you're not using the dir flags. All right. It passes Zig format now. Let's see if it runs. I probably should test this function independently because it'll be easier to test it independently than to test it if it broke in the real code. Okay, so first of all, expected type I32 found U32. Uh-oh, I think I passed the wrong FD somewhere. Yep. Pretty sure I did it wrong. Holy shit, I reversed the order of everything. Oops. Well, good thing I have types at all. Is there... Okay, I know this is a really stupid yak to shave, but I'm gonna solve this with Vim. Is it in exactly the wrong order, right? Yeah, okay, let's do this. Aw, man. Okay, that's, that's not quite what I was going for. Yo, Jacob Lee, what's up? No, that didn't work either. Tack? All right, let's try that. Oh, let's go. Okay. Oh, it's cat backwards. Holy shit. Wow, that's so clever. Wow. Okay. So those are in the wrong order. Also, creat doesn't exist. Oh, I know what the problem is. It's all namespaced and stuff. There we go. Okay, what's next? Flags. Expected type U16. Oh, yes. Okay, I'm going to need to do this at a bunch of places. 694. Yes. Okay, so. Let's do little niceties here. Okay. Right space. I don't know. FD flags. No, dirt flags. I think we're good, actually. What's this part? That's on runtime control flow. Okay, we'll get there. Expected enum found U16. Oh. It's just U16. Okay, that's fine. God, why is it the last terminal? Okay, FS flags is a U16. Okay, now we're here. 1806. All right, so the problem is these are all like comp time values and stuff. So let's try to make it. What's the simplest way to this? It'd be nice if this worked. It's supposed to work like the result location gets forwarded in there, but I guess that's not working yet. Cast the first if. Yeah, maybe that works. Let's try it. Which? Okay. 1807, same problem. Ah. All right, screw it. I'm just gonna do all the ifs. All right, expected type bool found U64. Yeah, fair enough. $1817, same problem. What is this, like double percent? Okay, 1824. Expected U32, found I32. Aha. Okay, so open at is returning us an unsigned assigned value, of course. Let's just do this then. All right, well, we're back to this part. I don't know what's going to happen. Anything can happen. Ideally, we'd get to the next to do. If it crashes, I think we should probably make sure to test the path. What is this called? I think we should probably test this function in like a small code snippet. Oh, well, we got to the next part. Stevie. Nice. All right, well, I'm going to call the stream. It's been 3 hours exactly. I feel like it. You trying to get me to do one more? Oh, man. No. I got to go. I got to make dinner for my wife, who's coming back from teaching like 3 classes in the same day. She's going to be hungry. But anyway, I hope that was fun. So, yeah, as an overview, if you got here late, the first 50 minutes of the stream, I was kind of just explaining the why of this. So go back and get that if you want some context for why we're doing this. Anyway, once this works, the next step would be to play with the C backend. Shout outs to Jacob Lee, who I just saw over there, and that will be part of the part of the strategy. So this is gonna be fun. It's gonna be really nice when we do that. We commit that deletion of this code, deleting this code from the repository. It's gonna be very, very satisfying. All right, well, thanks everyone for your time. And I'll try to stream again soon. I know I always say that at the end of every stream, but I'll see you again soon. All right, take care, everybody.